What's up, fellas? So, for centuries, the winter flounder thrived in the cold, nutrient-rich waters of the northeastern United States, supporting coastal communities and vibrant ecosystems alike. This flat fish, known for its unique ability to camouflage on sandy sea floors, has long been a staple for fishermen and a critical link in marine food webs. But over the past few decades, the story of the winter flounder has taken a troubling turn. Overfishing, habitat destruction, and warming waters have pushed this once abundant species to the brink. Populations have plummeted, leaving scientists, conservationists, and local communities scrambling to uncover solutions. Join us as we dive into the complex story of the winter flounder's decline, exploring the environmental, economic, and human impacts of their vanishing presence. Together, we'll uncover what's at stake and what's being done to save the iconic species before it's too late. Pseudoplura nectus is a genus of right-eye flounders, mostly native to northwestern Pacific Ocean, with one species found in the northwestern Atlantic Ocean, the winter flounder. It can be differentiated from the commonly co-occurring summer flounder by their small teeth and eyes nearly always positioned on the right side of their bodies. Meanwhile, summer flounder have their eyes on the left side of their bodies and possess large, conspicuous teeth. The winter flounder have an oval shape and thick body, and they have a straight lateral line and dark coloring. Their coloring often varies with their habitat, ranging from muddy to slightly reddish brown, olive green, or dark slate to an almost black upper side. Their underside is white, and their dorsal and anal fins are often tinged with pink, red, or yellow. The winter flounder live 15 to 18 years and grow to more than 2 feet in length, but are often found 8 to 16 inches. They spawn during the winter and spring in shallow, inshore waters, often returning to the same areas where they were born to spawn. Females usually produce between 500,000 to 1.5 million eggs. They deposit their eggs on sandy bottoms and algal mats at night, usually about 40 times every spawning season. Winter flounder feed during the day because they depend on sight to locate prey. Their small mouths limit what they can eat. They feed on small invertebrates, such as shrimp, clams, and worms. Mainly striped bass, bluefish, toadfish, and summer flounder. Birds, invertebrates, winter skate, and marine mammals prey on larval and juvenile winter flounder. Atlantic cod, spiny dogfish, and monkfish prey on the adults. Winter flounder are found in estuaries and on the continental shelf of the northwest Atlantic. From the Gulf of St. Lawrence, Canada, to North Carolina, they are most common north of the Delaware Bay. Winter flounder get their name because of their migrations. In the winter, adults migrate from offshore areas where they feed to inshore bays and estuaries where they spawn. While inshore, they live on muddy sand, clean sand, clay, and pebbly or gravelly bottom habitats. They often bury their whole body except for their eyes in bottom sediments. The winter flounder population we experience today is just a small fraction of what it used to be, especially during the 1970s and 1980s. Winter flounder once supported a massive recreational and commercial fishery along the Northeast. The species started to decline around 1984, largely due to overfishing. Nowadays, winter flounder is a highly regulated aquatic species that is largely managed. If you guys look at this graph here, recreational landings peaked in 1982 at 16.4 million pounds and have since maintained a declining trend. In 2016, recreational harvest in these locations was 72,765 pounds and 52,920 pounds, respectively. Overfishing has been a primary driver of the decline. Historically, targeted for commercial and recreational fisheries due to its mild flavor and accessible habitat, the winter flounder became increasingly susceptible to overharvest as fishing methods intensified. Troll nets, which were capable of catching large quantities of fish in a short amount of time, proved particularly damaging, especially to juvenile flounders and breeding adults. Despite efforts to implement regulations such as size limits and fishing quotas, the species struggled to recover, in part due to inadequate enforcement and the slow reproductive rate of the flounder. Winter flounders depend on estuarine and coastal habitats, especially muddy and sandy bottoms, for breeding, nursery grounds, and food. These areas are highly sensitive to environmental disturbances. Coastal development, including the construction of piers, bulkheads, and dredging for shipping channels, led to the loss and degradation of these critical habitats. Furthermore, water pollution stemming from agricultural runoff, industrial waste, and sewage polluted the estuaries where flounders spawn, reducing water quality and affecting the survival rates of their eggs and larvae. Climate change has also played a role in the decline of the winter flounder. Rising sea temperatures, altered salinity levels, and ocean acidification have disrupted the species' life cycle. Winter flounder are particularly sensitive to temperature change. Warmer waters can alter their migration patterns and reduce their ability to spawn in the same locations. In addition, shifts in the timing of seasonal changes, such as earlier springs or later winters, can interfere with the delicate timing of their breeding cycles. Juvenile flounders, which depend on specific conditions for survival, have been especially affected by changes in water temperature and ocean currents. In addition to overfishing, climate change, and habitat loss, the species face intense predation and competition from others. One theory suggests the decline of Atlantic menhaden put additional pressure on the winter flounder. Menhaden have declined 90% over the past 30 years, which coincides with the winter flounder population. Another theory suggests the increase in blue claw crabs, which prey on juvenile flounders, have also hurt their numbers. There have been efforts to rebound the population. Fishing regulations and quotas, habitat restoration projects, stock enhancement and hatchery programs, ecosystem-based management, marine protected areas, and research and monitoring. In a recent study, Dr. Matt Siskey and his team investigated the life history strategies of winter flounder by analyzing their otoliths, or their ear bones. These contain chemical tracers that reveal a fish's movement and environment history. This research challenges some long-standing assumptions about winter flounder behavior, particularly the belief that all flounders spawn inshore and undergo seasonal migrations. The study found that, contrary to previous assumptions, not all winter flounder are spawned inshore or spend their juvenile years in coastal nurseries. Instead, a significant portion of younger flounder spent their early lives offshore, demonstrating that juvenile winter flounder can inhabit both inshore and offshore environments. The research also revealed that only about half of the sampled winter flounder engaged in seasonal migrations. The other half remained either in coastal or offshore habitats year-round. This form of partial migration is seen as survival strategy, where different groups of fish follow different life history paths to enhance population resilience. The study identified 4 primary life history strategies for winter flounder: bay residents, fish that live inshore year-round; bay migrants, fish that migrate between inshore and offshore habitats; ocean residents, fish that live offshore year-round; and ocean migrants, fish that migrate between inshore and offshore habitats. Growth rates varied based on habitat and migratory behavior. For example, migratory fish, which tend to move between habitats, grew faster than resident fish that remained in either coastal or offshore environments. The study's findings suggest that the current management models for winter flounder, which often assume a simple inshore spawning and migratory pattern, may be flawed. About 75% of the sampled fish did not fit the traditional bay nursery migrate model, highlighting the need for fisheries management to consider the full range of life history strategies. Dr. Siskey emphasized that management efforts should distribute fishing pressure across all 4 life history strategies to avoid disproportionately impacting any one group. For instance, because migratory fish tend to grow faster and may reach the legal catch size earlier, they might be more vulnerable to harvest under current regulations. One next step is to integrate these new life history findings into stock assessment models to better predict the population dynamics of winter flounder. This study underscores the complexity of winter flounder behavior, showing that these fish don't fit neatly into the management frameworks that have historically been used. As Dr. Siski noted, we must listen to what the animals are telling us. Despite these efforts, the winter flounder population remains at critically low levels in many parts of its range. In some areas, flounder populations are showing slight signs of recovery. The fate of the winter flounder serves a reminder of the complexity of marine conservation, where the success of one species' recovery depends on broader, coordinated actions across multiple environment and human factors. Fellows, if you have any winter flounder knowledge or stories, please tap into the comments. Once again, thank you for watching, and folks, we'll see you in the next one.